Hi everyone. Today we'll be learning about classification of oxides and pH of soils. So if you have your theory book, can you please turn it to page 92? All right, so let's begin. Okay, so this is what we're learning today. In terms of learning goals and success criteria for today, we will be learning about the characteristics of different types of oxides, namely the acidic, basic, amphoteric, and neutral oxides. We'll be learning about how the different types of oxides are able to undergo different types of reactions. And over here, we will mainly be focusing on the reaction neutralization. We'll be learning about also about the applications of pH, and the example that we will be focusing on will be planting of crops. For success criteria, at the end of the lesson, you should be able to categorize oxides into different categories: acidic, basic, amphoteric, or neutral. What I mean is that if I were to give you an oxide like carbon dioxide, you need to be able to know which category it falls under. Okay, you also need to be able to state the observations of different oxides when tested with indicators. So, for example, if I have an acidic oxide and I expose it to moist litmus paper, like moist blue litmus paper, you need to know that it will be able to turn it red. Okay, and we also should be able to state the type of reaction that the different types of oxides will undergo. And lastly, you should be able to explain how to adjust pH of soils for planting crops through the use of the chemical slake lime, which is solid calcium hydroxide. Okay, so let's begin. Okay, so this is page 92, classification of oxides. Like we said just now, there are mainly four broad categories of uh, oxides that we're looking at. Okay, acidic, basic, neutral, and amphoteric. And to just backtrack a bit, what are oxides? Okay, we have learned what are acids. We have also learned what are bases. Okay, so these are the broad categories. However, the next category in terms of oxides, which is actually oxygen, a compound containing oxygen and another element, this these can be classified under whether they are acidic, basic, or amphoteric or neutral. Okay, so generally, the idea is that if I have an acidic oxide, it would have acidic properties. Okay, maybe let me just write it inside the different categories in the page. Okay, so like I was saying, if it is acidic oxide, it would have acidic properties. But because it's still an oxide, it is not dissolved in water yet. Okay, these are generally not dissolved in water. So in order for the acidic properties to appear and to yeah, in order for them to appear, you need to first dissolve them in water. Then you will see the acidic properties appearing. So uh innately it is able to display acidic properties. However, it must still be dissolved in water first in order for these properties to appear. Okay, so what are acidic properties? We just go through category by category. Acidic properties are generally non-metallic oxides, and like we said just now, in terms of reaction, is able to react with bases to form salt and water. So what is this reaction that we're talking about? This reaction is neutralization. So this falls under the category of our acid plus base, the general reaction, right? You get salt plus water. So this is something that you have already learned. So what are some examples? Okay, as we look below, what are examples of acidic oxides? Firstly, they are non-metallic oxides. So let's look through. In terms of non-metallic oxides, which are the ones that are non-metallic? Okay, this is non-metallic because it's carbon. Okay, so refer back to your periodic table, that staircase dividing line. What else are non-metallic oxides? This is also non-metallic oxide, nitrogen dioxide. Then we have nitrogen monoxide, sulfur dioxide, sulfur trioxide, and water. These are all the non-metallic ones. Okay, and the rest are metallic oxides. Um, but also just to share with you, there is another category that is actually non-metallic oxides, and that is under the category neutral oxides. Okay, neutral oxides actually also are non-metallic oxides. However, they are mainly non-metallic monoxides. They are mainly non-metallic monoxides. So what does monoxide mean? Monoxide means there's only one oxygen. You only see one oxygen. So out of these non-metallic oxides that we saw just now, okay, if this portion has only one oxygen, it means that the acidic oxides over here, these will be dioxides or trioxides, or basically the idea that there is more than one oxygen in this compound. Okay, so this is how we differentiate between acidic oxides and neutral oxides. Neutral oxides, non-metallic, only one oxygen. Acidic oxide is non-metallic, but there are more than one oxygen. So out of the list, which are the non-metallic dioxides and trioxides? Okay, so that will be here. This is di, right? Sulfur dioxide and sulfur trioxide. So let's write it down in our book. So we have nitrogen dioxide. This has the formula NO2. Then we have sulfur trioxide, SO3, and sulfur dioxide, SO2. Okay, please write it in your book. Okay, so with that, let's just take a look at the neutral oxides first, since we're talking about it. So these, if you look at the characteristic and the reaction, okay, they they do not react with either acids or bases. Okay, they do not react with either acids or bases. The reason is because over here, the entire page, the underlying reaction that we're talking about is actually neutralization. This is the reaction that we will actually be focusing on. So since it is neutral oxide, it will have the characteristic that it is a neutral substance, right? So this would have the properties of a neutral substance, neutral compound, chemical, and hence, because it is already neutral, they will not undergo neutral, they will not react with acids or bases at all, because they cannot neutralize the acid or base. Okay, so that is why they do not react with either acids or bases, because they are unable to neutralize them. Unable to neutralize acids and bases. Okay, so please write down all these notes in your book. So what are our examples? Okay, it will be carbon monoxide, formula CO, right? Mono, so that's one. What else do we have? Okay, we have nitrogen monoxide. Again, mono, that's NO. And then lastly, water, formula H2O. So you can see that they are all compounds which are non-metallic and they only have one oxygen. Okay, so moving on, basic oxide. Basic oxide would be, like the name says, it is a base, right? They are generally metallic oxides. Okay, so they are generally metallic oxides, like what we learned previously about bases. And they, in terms of reaction, they react with acids to form salt and water. So again, underlying here, the reaction that we're talking about is neutralization. All right. Before we go to the examples of basic oxide, um, so let me just backtrack. These have basic properties, right? So they are properties of a base. Okay. And yeah, before we go to the examples of basic oxide, let's look at amphoteric oxide as well. Amphoteric oxide is also, they are actually also metallic oxides, similar to basic oxide. However, there are only three of them. Okay, there are only three of them. What are the three of them? So this is one that you must memorize. Okay, Z. What does Z mean? The Z over here stands for zinc, aluminium, and lead. Okay, why lead? Why is lead P? Because in terms of the chemical formula, the chemical symbol, we have Zn, Al, and Pb. Okay, so this is why it has the acronym ZEP. So what are amphoteric oxides? Amphoteric oxides are somewhat in between acids and bases, okay, because they are able to react with both acids and bases. So it is able to, in a sense, neutralize acids, is also in a sense able to neutralize bases. So they are like the in between between acids and bases. Okay, so because it's only three examples over here, therefore we are actually looking at aluminium oxide, zinc oxide, and also lead 2 oxide. Okay, so let's write down first. Lead 2 oxide. Please remember the bracket 2. And zinc oxide. Hence, the remaining that we're looking at that are metallic oxides like copper 2 oxide, magnesium oxide, sodium oxide, these will be basic oxide. So please write them into your book. Okay, so usually we like to use a Venn diagram to help us remember what's the pattern in the reaction of these four types of oxides. So maybe let's just draw it over here. Okay, so in terms of a Venn diagram, we basically look at it this way. The first circle here represents chemicals that able to react with acids. The second circle over here represents chemicals that are able to react with bases. Okay, can you please write down this? So how do we categorize them? For acidic oxides, because it is our underlying reaction is neutralization, they will fall under the category able to react with bases. On the other hand, for basic oxides, they are able to react with acids. Just now we said that amphoteric oxides are special oxides that are able to react with both acids and bases. So they will fall under the center category here. Whereas on the other hand, for neutral oxides, they are unable to react with acids, they are also able to react with bases. Hence, they will fall outside of the Venn diagram. Okay, so hope this is able to help you to remember them better. So basically, this is the one that you need to remember how they react, and the other one that you need to remember will be how to characterize, how to categorize them, how to categorize them. Okay, so maybe let me just write it at the bottom here, how to categorize them. In terms of the types of oxides, we firstly look at them as whether they are metallic or non-metallic. Okay, under the metallic oxides, there are two broad categories. The first one is ZAP, only for zinc, aluminium, and lead, and this will be amphoteric oxides. So all other metallic oxides will fall under the category of basic oxide. For the non-metallic oxide, I will categorize them by the number of oxygens that they have. Okay, if there is only one oxygen, this would be neutral oxides. But if there are more than one oxygen, then this would be acidic oxide. This is just a general rule of thumb. There are also exceptions to the one oxygen and more than one oxygen example. Okay, if we come across them, I will highlight them to you. But generally, this is how you categorize them. So please remember this as well. Okay, so let us just go through very quickly what uh what are the what are these? Okay, are they acidic, basic, amphoteric, or neutral? So you may want to just pause your video first to to try this on your own. Okay, and then let us just go through this together. Firstly, let me just take a look if there are any amphoteric oxides. Okay, so let us just run through the amphoteric oxides first because there are only three of them. For amphoteric oxides, remember is our Z. So let's look through. Here we have lead 2 and here we have zinc, right? So these are amphoteric. Next, the rest of all the other metallic oxides will be basic. Okay, so which are the metallic ones? Barium, calcium, iron. Yeah, these three. Okay, so let's write down, this will be basic oxide. For the acidic oxides, they will have more than one oxygen and they are non-metallic oxide. Okay, so which are the ones? Here we have iodine pentoxide. Pent over here means 5. It's like pentagram, right? Pentagon, rather. We have here also phosphorus pentoxide and silicon dioxide. So these are acidic. And for our neutral ones, it will be here, mono, right? So these are neutral. Okay, so that's the first part for the types of oxides.